Okay, this video is the first one for section SEQR E. In this video we're looking at geometric sequences and series. Now in a sequence, when one term is related to the preceding number by multiplication of a common factor, the sequence is a geometric sequence. So you remember with arithmetic we're adding each time, now we're multiplying each time. Our first term is still a subscript 1 and our common ratio is r. The common ratio can be an integer, a fraction or a decimal, so basically you can multiply by anything. It could also be positive or negative. Okay, so what we're looking at here is if our first term is a1, our second term is going to be a1 times r. Our next term is going to be what we just had, so a1 times r times another r. Then we're going to have ar times r times r times r. I think you get the idea. So it's a1, then a1r, a1r squared, a1r cubed, and we'll go all the way up to a1r to the n. Okay? So a couple of examples here, 3, 6, 12, 24, 48. You can see that to go from here to here, we're timesing by 2. Here to here, timesing by 2. So work out the common ratio. It's just one term divided by the other, and they all equal the same thing. Okay, so if I divide one term by the previous term, I'll always get, sorry, that should have been 24 there, 2. So in this case it's geometric. a1 equals 3 and r is 2. In this case here, r is going to be negative 50 divided by 500. That's going to be the same as 5 divided by negative 50. It's also going to be the same as negative 0.5 divided by 5. So you're dividing by that same thing each time. Probably easier to keep it as a fraction. In this case it's going to be a negative. If I simplify, take off a 0 from each one, divide the top and bottom by 5, so I get 1 over 10. So it's geometric. a1 equals 500 and my common ratio is a negative 1 over 10. Okay? You could have also answered as negative 0.1, but it's probably easy to leave as a fraction. So hence the common ratio r can be calculated using, and you can just see one term divided by the previous, one term divided by the previous. To generalize that, we can write it as r equals a to the n divided by a to the n minus 1. Now the nth term, which is an of a geometric sequence, is defined by, so here's our general term, our general formula, a subscript n equals a1 r to the n minus 1. So let's look at some examples. Determine which of the following sequences are geometric and hence calculate the common ratio in the 8th term. So let's start by going term divided by the previous. So 21 divided by 7 is 3. 63 divided by 21 is 3. 189 divided by 63 is 3. So therefore this is geometric. Okay, we've got a1 is 7 and r is 3. Now our general term an equals a1 r to the n minus 1, so my 8th term is going to be 7 times 3 to the power of 8 minus 1. Okay, so 7 times 3 to the power of 7. Go to your calculator. 7 times 3 to the power of 7 is 15,309. Okay, so that's your A8. That's your answer. Next, okay, let's start dividing. 11 divided by 7, well, it's not a fraction, so like it's not a simplified fraction. If I'd work that as a decimal, it's approximately 1.57. 15 divided by 11, 15 divided by 11 on your calculator is approximately 1.36. So this is not geometric. There's no common ratio. Okay, next, negative 50 over 500. Okay, that's negative 1 over 10. 5 divided by negative 50 is also negative 1 over 10. And it's the same sequence as what we had before. So therefore this is geometric. My A1 is 500 and my r is negative 1 over 10. So let's try and find what A8 is. Write out our formula. So my 8th term is going to be 500 times negative 1 over 10 to the power of 8. Okay, you can answer as either a fraction or a decimal. You know that this is going to become positive because it's got an even power. So you've got 500 times 0.1 to the power of 8. And you get 0.00005. Okay? And that's your 8th term. Next. 1, 2, 3, 4. I just missed a 0, I've just realised. If you work it out in your calculator, it's actually 5 times 10 to the negative 6. So it actually should be 1, 2, 3, 4, 5 there. Okay, next one. I'm looking at that and know that it's not geometric, but anyway, 1 divided by 1 is 1, 2 divided by 1 is 2, so therefore it's not geometric. Always show why it's not, don't just state it, even though I could just see it. Next, given that a geometric sequence has a first term of 3 and a common ratio of 2, list the first 5 terms of the sequence. So A1 equals 3, R equals 2. So let's list them. So A1's 3, A2 is going to be 3 times 2 is 6, A3 is going to be 6 times 2 is 12, A4 is going to be 12 times 2, which is 24, and A5 is going to be 24 times 2, which is 48. Okay, so therefore, first 5 terms are 3, 6, 12, 24, 48. Next, for the sequence 1024, 512, 256, find the 10th term. Now we do have 2 types of sequences now. We've got arithmetic and geometric. You need to show which one it is. You can't just assume because you're not going to know which one it is in a test, so you need to say. So my first step here is going to be 512 divided by 1024. Okay, on your calculator, 512 divided by 1024 is 0.5. Then I'm going to do the next number, 256 divided by 512. 256 divided by 512. It's also 0.5. So therefore it's geometric. A1 is 1024 and R is 0.5. So from there I need to work out what the 10th term is. So I want that A10. So AN equals A1 R to the n minus 1. So A10 is going to be 1024 times 0.5 to the 10 minus 1. So 1024 times 0.5 to the power of 9. Plug that into your calculator and you get the answer is 2. Okay, therefore 10th term is 2. Next one, which term is equal to 16? So I know that AN is 16, but I don't know what N is. So AN is A1R to the n minus 1. 16 equals my first term, which was 1024. R was 0.5, and to its power to n minus 1. From there, divide both sides by 1024. Now if I put that in my calculator, I get quite a long decimal, so I'm going to leave it as 16 over 1024 is 0.5 to the n minus 1. This is where we need to do logs, okay, because we need that exponent. So you can either think of taking the logs of both sides or just rearranging it in form of a log. Okay, so if I take the log of both sides, I get ln of 16 over 1024 equals ln of 0.5 to the n minus 1. So I've got ln of 16 over 1024 equals n minus 1 ln of 0.5. So dividing, and I'm going to run out of room, all over ln of 0.5 equals n minus 1. So that means my n is going to be all of this. So ln of 16 over 1024 divided by ln of 0.5 plus 1. Plug that into your calculator and you get 7. You'd have to finish with the therefore statement. I don't have enough room, so to be therefore the 7th term is equal to 16. Last example, if the 3rd term in a geometric sequence is 45 and the 7th term is 3645, find the 12th term. You should be thinking this is going to be simultaneous. Okay, so my 3rd term is 45, my 7th term is 3645, and I want to know what my 12th term is. So let's write out our general term. It should be r, the m minus 1. So let's use the a3. So a3 equals a1 r to the 3 minus 1. So 45 equals a1 r squared. I'm going to rearrange for probably a1. So a1 equals 45 over r squared. Let's look at our other term. a7 is going to be a1 r to the 7 minus 1. So 3645 equals a1 r to the 6. Okay, rearrange, a1 equals 3645 over r to the 6. Equation 1, equation 2. 1's going to equal 2, so I've got 45 over r squared equals 3645 over r to the 6. From here, what I'm going to do is just swap my numbers. So I'm going to swap these ones here. So I'm going to get r to the 6 over r squared equals 3645 over 45. Again, you would work down your page. We're going to come up here. R to the 6 divided by r squared is r to the 4. 3645 divided by 45 is 81. To get what that r is going to be, I'm going to put both sides to the power of a quarter, because 4 times a quarter is 1, so I'm left with r. Now it's an even power, so my answer is going to be a plus or minus. 81 to the power of a quarter gives me 3. So that's plus or minus 3. Okay, so I've got two answers. When r is 3 and r is negative 3, I'm going to sub back into equation 1, which is this one here. So a1 is going to be 45 over 3 squared, 45 over 9, which is 5. Here, a1 is going to be 45 over negative 3 all squared, which again is 5. Okay, so I've got two solutions. a1 is 5 and r is 3, or a1 is 5 and r is negative 3. So when I want to work out what a12 is, that's a1 r to the 12 minus 1, or a12 equals a1 r to the 11. I have to have two solutions. a12 is 5 times 3 to the 11, and a12 equals 5 times negative 3 to the 11. Okay, here I get that answer, and here it's going to be exactly the same answer, but the negative. So you've got a negative out the front. Okay, I've run out of room, so remember a therefore statement. Therefore, the 12th term is either 885,735 or negative 885,735. So it's probably a good one to try and do yourself. Next, exercise in your textbook, SEQR E1. Again, problem solving is more difficult than the basics. If you're having problems, make sure it's not the basics that are an issue. Okay, so question 4 in that exercise is problem solving, but the first 3 questions are just basic skills, so make sure you understand those.